All right, everyone. So we're going to get started here looking at our reflections in curved mirrors. Right? Starting off, we're going to be starting with concave mirrors. Which are otherwise known as converging mirrors. Now, before we actually get into the ray diagrams that we're going to be doing, just a few things that I want to kind of cover are some of the main kind of terminology points for these types of activities. So you will notice that on really every single diagram that you are given here involving a converging mirror or a concave mirror, or even our convex mirrors, you are going to see that you are given two specific points on this line. Now, first off, this line here is what we call the principal axis. And essentially all that is going to be is a reference point for us to work off of while completing these problems. Now, the principal axis is unique because it is going to pass through two specific points, right? One of which is going to be our center of curvature, as well as our focal point. Now, if we were to look at this individual mirror as a full circle, I did create it using this here compass. This center of curvature will equal the very center of that circle if I were to make a full circle using my compass. So if I look here, right, I can see that that individual compass, if I hold it on the center of curvature, is going to follow that perfectly. Right now, ideally, we are never really going to have a full circle, but if I wanted to, I could actually take my compass all the way around, creating an entire circle. So that is the very center of that circle if I were to have an entire circle of mirrors. However, in this situation, we're only going to use a portion of that individual circle. Now, our focal point here is going to be exactly halfway in between the center of curvature and the face of the mirror. Right? If I take my ruler here, I can see that the center of curvature is 12 centimeters away from the mirror. Right? So that is 12 centimeters, where the focal point is only going to be 6 centimeters away. Right? So sometimes we will see that these 2 points are actually denoted using symbols. The focal point is always going to be identified as F. And sometimes we will see that the center of curvature may be identified as C, but more often will be identified as 2F. Now, really all that means is that it is twice the distance away from the mirror as the focal point, okay? So now using all of these things, we can kind of get into some specific rules that we can follow when looking at these mirrors. The very first rule that we will see is that if any ray of light is to come directly through the center of curvature, it will bounce back and the reflected ray will be along the exact same pathway. So let's say I had a specific ray. Here's my incident ray going into the mirror, right? So let's denote that as a incident ray. You will actually notice that your reflected ray is going to come right back down that pathway. Right? So when we are dealing with anything passing through the center of curvature, right, we are going to see that those follow the exact same pathway for the angle of incident, or sorry, the ray of incident ray or the reflected ray. Now, there are a couple other rules. These ones are probably the more important rules for us involving the focal point, right? If any ray of light, doesn't matter where it is, it could be up here, down here, anything that is running parallel to the principal axis. So if I just draw an incident ray here coming from some region running parallel to this principal axis, right? So this would be my incident ray. It is going to have a reflected ray that is going to come directly through that focal point. Right? And this is really where we get that term converging lens, right? Every single parallel ray that is coming into this is going to relay all of those rays back through the focal point for the reflected rays, right? So we can kind of use that as a opportunity to try and figure out where things are located. In addition to that, we will also see that if you have your original incident ray passing through the focal point, coming from some region, it will go here, pass through the focal point. It is then going to follow pretty much the exact same thing, and it is going to be reflected parallel to that principal axis. Right, so those are kind of the rules that we have. So when we work into an actual problem here, right, the two main rules that we are going to be functioning off of are the last two that I spoke about here. So the first one, right, if we're talking about our first rule, it is that any ray, any incident ray traveling parallel to the principal axis will be reflected through the focal point. And I actually should have done that one red because I'm going to use a red pen to demonstrate that individual rule. And then our secondary rule is going to be in blue. And that secondary rule is going to tell us that any incident ray passing through the focal point is going to reflect parallel to the principal axis. So any incident ray traveling traveling through the focal point will reflect parallel to the principal axis. So really using these two rules here, right, we will be able to complete the entire ray diagram for this activity. So the first one I'm going to follow, okay, rule one, knowing that any incident ray that is traveling parallel to the principal axis will be reflected through the focal point. So in all of these diagrams, you're always going to start at the top of the arrow or the object that you are given, right? So most of the times when I do give you a problem here, it will just be a simple arrow. So if I am going to complete a question like this, the very first thing you're going to do is draw a line as close to parallel as possible, right? Normally I just look underneath the ruler, make sure that these two gaps are approximately equal to one another, and then I'm going to draw a straight line into that mirror. Okay, again, our process is going to be the same. I'm going to put a little arrow here to show that this is an incident ray. Now we know, given the rule, right, if it is traveling parallel to the principal axis, which this incident ray is, the reflected light is going to come directly through the focal point. So then I can take from the point where that incident ray is going to contact the mirror, and I'm going to reflect that back directly through my focal point. And again, I'm going to put a little arrow on it, just so I know that that is a reflected ray. Right, so that is rule number one out of the way. Right now, rule number two, we know that any incident ray that passes now through the focal point is then going to reflect parallel to the principal axis. So I can then take my ruler, right, starting off from, again, the very point of the arrow, right, I'm going to take my pen, making sure that I have a line going directly through the focal point and contacting the surface of the mirror. Now I know here, I will put in my arrow to show that this is also an incident ray. And then that is going to, once again, reflect parallel to the principal axis. So I'm going to take my ruler, right, making sure that it is as close as possible, parallel to the principal axis. And I will see that there is going to be a location where this reflected ray and the reflected ray from our opportunity 1, those are going to intersect. Now what we are going to see is that is going to represent the point of the arrow that we were looking at originally. So my point is going to be at that point of intersection, and then I'm going to draw a line up to the principal axis. Now I've actually made a little bit of a mistake here, right? Really thinking about this type of problem, right? My answer should have been just slightly over to the left, right? That will be a result of just simply having these lines not running perfectly parallel to the principal axis, or maybe slightly having my focal point and my center of curvature off, right? But approximately these two are going to be roughly in the same place. And if I measure them here, I can see that my original object was 4 centimeters tall, and my reflected object is also going to be approximately 4 centimeters, right? So that is in the scenario that we have our object sitting right on top of the center of curvature. However, if we move to kind of some other scenarios, right here, I am given an object that is well beyond my center of curvature. So here, if I see this object, again, I start off by using scenario 1 with my incident ray coming into the mirror, right, and reflecting back through the focal point. And then I have my scenario 2 where the incident ray is going directly through the focal point and reflecting back parallel to that principal axis. Now, when I see this, I'm going to see that the point of intersection is right here. So my reflected object is going to be approximately there. Now, you will notice if you look at a scenario like this, right? This here arrow, exact same as the other one, is going to be 4 centimeters. However, if I measure the second arrow, I'm going to see that it is only approximately 2.5 centimeters, right? So that arrow there is smaller. You will notice that in every single one of these scenarios, right, the reflected object, or sorry, the reflected image is always going to be upside down, okay? And we'll kind of talk about that in the next little short video I create. Finally, I'm going to give you one more scenario where the original object is going to be located in between the center of curvature and the focal point. Again, following the exact same process, we are going to see that those two rays are going to intersect here. Now, my original image is going to be 4 centimeters again. If I do go and measure my reflected image, I'm going to see that it is approximately 6.5 centimeters. Okay, so we start to see some patterns that we can follow here, and we'll see those in this next section. So what we're going to use if we are using these mirrors to try and help describe what we are witnessing or what we have created, we use this acronym called SALT, and that stands for size, attitude, location, and type. So when we are talking about size, right, it is simply just talking, is it the same size, is it larger, or is it smaller? Right? So ideally, in the first situation that we saw, we are going to notice that it is the same size. In the second situation, the reflected image was smaller. And in the third situation we saw there, the reflected image was larger. And that is all based off of where the original object is in relation to the center of curvature and the focal point. Now, when we start talking about attitude, when we are talking about our converging lenses or our concave mirrors, the attitude is always going to be inverted. Okay, so inverted essentially just means that the image is going to be upside down from the original, right? So here, if it was the same side or the same way, it would be considered upright. But because we can see that the individual arrowheads have now flipped from top to bottom, right? This would be deemed an inverted image, right? And then looking forward, the next one is location. Where is that location of the image in relation to the original object? So was it closer to the mirror? Was it further away from the mirror? And then here we can also add some additional information saying it was beyond C or beyond the center of curvature, or it was between the center of curvature and the focal point, or it was between the focal point and the mirror. So we can add some additional information there for location, but really this is kind of the bare minimum that you should be implying. And finally, the last one is type. Right? Type determines whether the image is going to be a real or a virtual image. Now you'll notice in our converging lenses or our concave lenses, in contrast to what we saw with our plane mirrors, right? these images are going to be real images, okay? If we look here, right, they are located on the same side of the mirror as the original object was, right? So that is going to be a real image, right? It is not going to appear that that image is beyond or behind that individual mirror, okay? So these are all going to be real images, right? There are not going to be really any virtual images when we're speaking about our concave mirrors, right? So just kind of a last little summary for what we saw here. We can actually make one of these called a SALT chart, right? Talking about each one of these individual components based off of where that object location is. So the first one asks us, well, what is the SALT going to be, depending on if the fact that the object is located beyond or further away than the center of curvature. So if I go back through my examples, I can pull up the example that we did where my object was further away from the mirror than the center of curvature. Now in this situation, we can see that the size here, it was 2.5 centimeters versus the 4 centimeter original object. So we can go in and we can say that the size is going to be smaller than the original. Okay, if we start talking about attitude, every single time that we see attitude in these types of questions, we are going to see that the arrowhead is no longer pointing upwards. It is now pointing down, so the attitude is going to be inverted. And you will see that that goes the same for each one. The location, it is going to be between the center of curvature and the focal point. So I can write that down for location. Between F2 and F, right? Which is the center of curvature and the focal point. And then finally, we have type of image. Because it is on the same side of the mirror as the object was, this is going to be a real image. Now, when I look through my problem where the object was located at the center of curvature, which was right here, right? First, we are going to see that we measured these two objects and they were both 4 centimeters. So the size is going to be the same as the original object. The attitude is still going to be inverted. Now, theoretically speaking, this really should be directly below this center of curvature, right? So even though I did make a little mistake, right, really this should be moved over right underneath. So the location is going to be directly below F2 or center of curvature. And again, this is going to be a real image. It is on the left side or the object side of the mirror. And then finally, we can look at our last example, a point between the center of curvature and the focal point. We can see here that my reflected image is much larger than the original object, right? So larger than the original. It is still going to be inverted, as we can see here. The image is going to be beyond or further away than the center of curvature. And once again, it is on the same side of the mirror as the object, so this is going to be a real image. All right, so hopefully that helped, and then we will start up a new video here shortly involving our diverging mirrors or our convex mirrors.